points of contact going up. If equipment has to be brought up, I'll show you on the inverters. There's pieces that can come down, but they are relatively serviceable. They go in a backpack and people can climb down. So,
When people are coming up here, should they be wearing hard hat?
Not necessarily, no.
Okay.
sort of it's your operational prerogative.
Yeah, that's your guys' safety
Yeah.
procedures.
Even if it's not a hard hat, it could be a ball hat. Especially if you're coming through here, it's just something that's a little lighter.
I'm just thinking health and safety,
Oh,
and with
wonder
the
how-
health and safety team, I'm sure.
It'd be your help. It's up to
Yeah.
them,
Yeah.
right?
I think if it's, yeah, you'll probably want something up here.
Yeah.
Yeah, and this is all staying, these guardrails.
Yeah, this
So
rail
the
stays.
big thing, like I'll just speak for my field guys, is if they're bringing tools up, it's going to be with a rope coming up, not in the hands.
Not carrying it.
So people need to have hard hats if they're down below. So our guys usually have to wear hard hats, unless they're IR imaging or there's something that's, there's a reason for them not to.
Need to look at a process for coming.
And then, yeah, this ship's ladder, you have to always be facing the ladder. So it's like a
Okay,
regular
up and
ladder.
down.
Sometimes people try to take it quickly. That's how problems happen. Yeah.
So is that the lock, that rain handle?
Yeah,
unlock
so
it
you
and then
pull
you
that,
unlatch?
and it,
That's
yeah,
locked it up in
and it
position right now.
ratchets so it doesn't flip down, and then you've got to lift that to get it
It's
back
hydraulic
in.
assist, right? So you can get it up so far, and then you have to give that extra little push for that.
Yeah. It's not going to come tipping down on your head,
Yeah.
basically. Yeah, I mean, this is nice. Usually what we see is a fixed ladder vertical. It's a very small
This is a nice one.
opening. Yeah, this is very serviceable. A lot of this, part of the reason for this is you've got a lot of equipment. It's equipment, it's mechanical equipment.
Yeah. So a lot of contractors are going to need to get up here, right? So health and safety insurance documents are going to be important to have for all the
100%.
That would be
contractors.
anyway if somebody's coming up here.
Yeah.
So that's perfect.
Okay.
That's freaking awesome.
Thanks for drawing attention to that. Do you want to close that up?
Yeah.
These walkways are getting finished yet, or
Rearranged.
rearranged? Yeah. So that's the other thing. You want to make sure your baseline records stay on the walkways,
Yeah.
so that you don't damage the roof.
So you open that from up here, right?
Yeah,
Like,
you're
there's
gonna need to
no
put a
chance of
padlock
that
on
blowing
the
down and getting stuck up here, right? Like,
Up here?
Not really, no. You would normally padlock that from the inside. So if someone climbs on the roof, they can't access in. And then and then when somebody come up, you take that padlock off and leave it inside. The door would be up.
okay.
So.
It's probably not plywood.
Otherwise, no, yeah, like the handle's on the outside.
Okay.
Yeah.
I was
Okay,
totally
we'll see
getting
what they
stuck
come up
up
with.
here.
Yeah, no.
So we flagged the conductors. These are part of the runs back from each quadrant. So this one is the quadrant we're going to visit over here. That one's over there. So that's the one thing you asked about snowing in the winter. That is a risk, right? So we'll have to sort of see. It might make sense. These you can step on. You're not going to damage it. It's armored. But it might make sense to have a couple of
Flags.
just whips or whatever, right? So that people can see, oh, this is the pathway and there's something there. We'll keep going this way.
Especially if it's like last minute. No.
Snow City too.
Put a tape on that one.
Yeah. Wow, I think we're going to shift that.
Oh, no, that makes sense. For sure.
Okay, so we'll wait till everybody's here. Just coming along here. So we got a couple things to look at here. So one is you've got an up close and personal view of the array. So that's 3 panels in portrait it's called, so like a sheet of paper lined up that way. And then if you look underneath, there's a bunch of wires and a little black box. Those are the optimizers. Let's see. Probably easiest if you look at the top one there. So as you can see, it's tucked up underneath the array. So the main way to get at that, if the optimizer has to be replaced, is to unscrew the panel. They screw down from the top, lift the panel, put the new optimizer, and put the panel back down. Now, the way you do that in operation for fall arrest is that you have a temporary anchor point that's clamped to the seat. It's usually got 6 or 8 clamping points, and then they can tie off to that because everybody has to be tied off if they're on the roof.
Is there one that's integrated into the design that's permanent that we can use?
No. The challenge with permanent ones is that they have to be inspected every year. They have to be maintained, and ideally, you're not going up there very often. So, yeah. The wires come down. There's a PVC, and this is typical for all the arrays, transition box. So the unprotected wires come out of the array into that box, and then it transitions to this armored cable. So that armored cable then runs back to the inverter units. You can hear them ramping up. That's because the sun popped out from behind the clouds, and so they're working hard. Basically, it's fans that are running to keep it running.
So this is two sets.
This is 2 sets of inverters. So each one of these is 50 kilowatts. So this is the master control center. This is where the DC comes in. There's fuses inside there. There's an isolation switch, and then it goes to the 3 power stages. So what's nice about this is if you have a failure, you can pull power stage, take it, replace it, put the new one in. So you're not taking a big inverter down through the ship's ladder. Yeah.
It goes up to those, right?
Yeah, so what,
Does that go out to the room or does it go up? It goes out that way, right?
so it comes this way, flows out of here. This is the first isolation switch I was mentioning to you. So this will take down the entire, this is the wing northwest, will take down this entire group. Okay, so that's on the 600 volt side. These are the individual inverter disconnects labeled per inverter, so inverter 5, inverter 6. These come in to the transformer and are combined. That's right, there's an extra, we avoided a splitter here because it goes into the transformer. And then from the transformer comes back, hits this one, and then from here it runs back along to the electrical ring. So it feels like a little bit of a zigzag, but all the smaller techs are the DC coming in, and the larger ones are the AC. Yeah, if you, again, you guys shouldn't have to be getting into this equipment, but to isolate the equipment, you turn this switch off. What that'll do is it will disengage all the optimizers, and each optimizer puts out 1 volt, basically to say, hey, I'm here. And then you can measure the voltage in there and count how many optimizers there are. Again, you won't be doing this, but for service technicians, and they can see if all the optimizers are reporting properly. So it's a nice system in terms of compartmentalizing it from the engine perspective.
Is it marked in the off position, like shows in the off position?
Yeah, so these switches are pretty common. It's I won't do it, but it's basically the same as that other one. It turns
Oh,
counterclockwise.
it's in here where you are?
Yeah,
Okay.
yeah. It's easy
That's
to-
all I
But again, you guys should never have to be here.
Okay.
If there's
You
ever
always say should never have to be here.
okay, so let me reiterate. If there's ever a problem, someone's here and doesn't know solar, just turn this switch off. Because the same thing will happen. It'll go to the safety voltages on all the DC side. Or if you're even better, turn it off downstairs. Same thing happens. Everything goes off, goes down to safety voltage. Yeah. Or call Jamie.
And then he'll send me.
Yeah. Okay, any other questions about this? Okay, so the other thing we have here, I picked this one strategically, is there's that antenna. So that antenna is what's called the transfer trip to Hydro 1. So it's the thing that communicates line of sight to the Marysville substation. You shouldn't have to do anything with it. Shouldn't be any maintenance. If there's some big windstorm and it gets knocked, your system will get disconnected because as soon as it loses the signal, it'll isolate. And at that point, it's time to call Hydro 1 and call a service tech.
And if that goes, that loses their control over the system, right?
Yeah.
So they would know that right away. We would know it right away.
Yeah, they use what's called a heartbeat signal.
Yeah.
So if there's any reason it drops, it isolates. Yeah.
Oh, it'll isolate the system automatically. So
Automatically. Yeah, it's a
it's
fail-safe.
a dead man switch.
Yeah, if it loses any communication, it defaults to off.
So then we'll know that right away. and
You'll
we
know
can
that
call.
based on the monitoring. Yeah,
Okay.
that's right.
Big-
Actually, you'll get a quiet email that shows up in your inbox and says, system's offline, no inverters reporting. So. Any questions? Okay. I mean, we can look
That's
at
the same
each.
thing over there. They're all the same.
They're all
right?
the same. Yeah. Yeah. So there's a slightly different configuration, but in general, the 600 volt wing disconnect is always the one closest that you're going to walk up to. So
One
if you
for
look
each
over there,
lane. Okay,
yeah.
Rachel Marion, okay.
So now the clouds came
Clouds
out,
are
the fans turned off. That's really where the noise is. And it'll sit quiet for a bit until the sun pops up. So, mhm. No moving parts, well, except for fans
Yeah.
and the IGBT, which switches. Yeah. The only other thing I guess to mention, there's monitoring equipment just around the corner on that roof. Should be this one. I just want to be respectful. Oh yeah, okay. I think it's this. I'm not going to walk past this,
Good call.
but that PVC box mounted on the wall there has an irradiance and a temperature sensor that comes into it, and then that runs back to the monitoring. So when you look on the monitoring, it'll tell the radiance or temperature. That's the communications for that. There's also, you see the thicker black cable beside the tech. That is from the antenna, so that's the run back. We should get them to label that, just so that's clear. That's all low voltage communications, but it's part of the solar. Excellent.
So we've had one full cycle almost, right, on this system. Like you said, you went through winter. Now you're coming.
So
through
we
spring,
did
working
we
right
did
through.
commissioning in the winter, and then there was quite a delay to get all the approvals and insurance and all that such figured out. We ran it in March as follow up, and then the official date of operation was April 10th. So it was turned on a couple of weeks after the 10th, and we left it on commissioning. We didn't get the letter from Hydro One until I was trying to chase it down, and then I noticed the back date on it. But the good news is we had left it running as part of the commissioning procedure, so you're already we're getting credits for that. So yeah,
we'll have a full system. We'll have a full year.
so we're going to do a full
April 1st.
year. We're involved still in comparing energy use and monitoring that year to make sure that it's performing the way it should. So we'll still be around and yeah, supporting it. But yeah, so it's been through a winter. We know what happens with the snow. It clears all of a sudden, right, when it gets cold. Or sorry, when it warms up just a little bit. So that's one point. But yeah, it's hasn't been operating through all 4 seasons yet.